Yeah, dummy regression is one of the important aspect in this regressional analysis, and most of the doctorate student they used to get stuck up with the data or the categorical data. They may be from the different region, different group, different genders, and they do have also numerical data. How to do the analysis all about it. So let us do the dummy regression for the two categorical variable for 3, 4, and uh, more. So dummy regression for the two categorical variable as such, there is the you have taken the category gender as the male and female, and there is n equal to 2 here. There are two category. We need one coding, like for the male it is 0, for the female it is 1. So I put all the male and female into the 0 and 1 coding, and the weight, the predicted, the weight is being calculated for the different male and female of the nine student of a class, and we want to predict their weight. So if you'll see, I take all the male total weights, I found it is 335, and the average weight of the male is 67. Similarly, female weights are 232 in total, and the average weight is 58. And the difference between these two group weight is 9. So now if I'll do the regression by taking the data analysis, if I'll do the regression by taking data analysis, so you can do the data analysis and you can take the your categorical variable as let me give so one example, then you can do afterward. So you can take weight in this y range as the dependent variable and the gender code as the independent variable. So gender code as the, and the you can put label and output wherever you want to see the output. We want to see the output. I have taken the output here. So accordingly you can put OK, then you will see the once you put OK, so as there is output, so it is showing, so you can see the output now. Can you see the output? And can you see the R square is so high? R square is here 0.55, means my categorical variable is predicting the weight. And can you see the significance of the model is also valid. And this you can see here, if you'll see the we saw the R square, we saw the correlation. We for the, can you see the intercept 67 and point minus 9? Minus 9 is the regression. You can say the all of you know the regression that beta 1. So beta 1 regression coefficient, and regression coefficient is nothing but the difference between the two groups weight. So if I'll differentiate 58 minus 67, it is minus 9. So now the regression equation is 67 minus 9 into gender code. So gender code when it is 0, so the male weight is equal to 67, and when the gender code is 1, then the 67 minus 9 into 1 equal to 58. So by taking the average also I was finding 67 and 58, and the difference between these two is 9. So we understood regression coefficient is nothing but it is the difference between the average weight of these two different group, and this intercept is the weight for the base weight for the male when the your code is 0. So this is for the two groups, and we got for this two group and for this predicted weight, and you can go through in detail, but let us go for the three. So we got, let us go for the 3, and 3 I added some transgenders also, and I also took their weight also. So for the transgender, now we got, instead of two groups, there are three groups, male, female, and transgender. And for this transgender, we have put the coding. The coding will be n minus 1. N minus 1 means there are three different category, and 3 minus 1 means we have to represent three different category into code of two codes. So like male I put 1 and 1, female I put 0 and 0, transgender I put 0 and 1. You can take also even 0 0 1 0 1, but you have to take from the binary codes. So if for the male I put code 1 and code 2 in the form of 1 1, for the female code 1 code 2 0 0, male again all the male are in 1 1 format, female are in 0 0 format, and the transgender are in 0 1 format, and the weights are there. I want to predict their weights. Again I did a regression. You can see the R square is high, it is more than zero point 0.6, and the prediction is good. And let us see the here the significance. If this model is also significant, let us see the significance of the code 1 and code 2. The p-value also we are finding code 2 is more significant than the code 1. And so these are the all differences. Can you see the male here? If I'll see the equation, this is 58.8 intercept minus 5.5 into code 1, then 13.7 into code 2. So if I'll go through this, if I'll replace this code 1, code 2 by this male 1 and 1, I'll get 67 as the male average weight. And for the female 0 0, if I'll replacing the female, I'll getting 58.8, and for the transgender, I'm getting 72.7. I have taken the total weight of the male that we are getting is 33 is 335, and similarly the averages. So the same averages we are getting through this model, and the difference of them are here 67 minus 58.8 is your 13 point, then minus 5.8, 67 minus this 58.8 minus 72, that is 13.7. So this regression coefficient beta 1 beta 2 is nothing but it is the average difference of the two different group, where the base is here 0 0, that is the female that is coming, and all of us can see the regression model significance, and we are finding its excellent significance. Similarly, go to the 4. So 4 different category I have taken, north, south and all, and there are 4. So n minus 1 means 4 minus 1, so we need 3 different binary codes to represent. So the base code is the north, and the south is the 100, west 011, and so by this we got a regression. Here the regression code we got. Can you see the regression base intercept 152, then b1 beta 1 beta 2 and beta 3. So if I'll take the regression equation is rice production is equal to, for the north south for the different years, is this the code, and if by putting the code, north is equal to 152 and south is equal to, if you put the code, replace the code these codes, and you will get this east equal to. So this is about the prediction of the north, south and east for the different year the rice production, and these are the prediction. And can you see the r square? R square is also excellent here. The r square is, we are finding 0.89. Let us see r square where it is a lower r square value, then we'll understand the significance of the r square. Now I got a blood pressure patient and blood pressure patient. Those who are having blood pressure, they are 1, not having, they are having 0. Then I have measured their blood pressure diastole and the hemoglobin. So by doing this, by taking the regression of the blood pressure with the blood pressure patient with the blood pressure diastole, I'm getting a regression r square very high, and I'm also getting their regression equation 83.7, and the blood pressure patient 32, the difference between the blood pressure and non-blood pressure patient. But while doing the same regression with the my hemoglobin, this hemoglobin of data of 10, I'm getting just a r square 0.19, and here you can see the significance is not there. So this model is not significant, and it is not predicting, even if it is giving some predicted value 12 as the intercept, and the difference between the blood pressure group non-blood pressure group is the 1. Still there is, we can see there is this model is not significant for this blood pressure with the hemoglobin. And this is also we found in nature. In reality also, hemoglobin is not connected with the blood pressure patients, but the blood pressure diastole is connected with the blood pressure patient. This is the way the whole you can understand the dummy regression and all. And let us see the dummy regression for this kind of data, where the male female is given, the cholesterol is given, the stabilized glucose is given, the glycosylated hemoglobin is given, the blood pressure 1 and 2 is given. So now how we can do the regression for the gender, for the location, for the framing wise, that with the on the basis of that you can do the regression all, and we can have an excellent result of the data analysis. This is very much useful for your data analytics. Thank you. Thanks for watching.